The 40 series launched with a lot of excitement, but I feel like that excitement has been dwindling, and I think this chart does a lot to explain why. Let's take a look. So the 40 series launched with the 4090, coming in with a 71% performance uplift versus the RTX 3090. Now, still had 24 gigabytes of VRAM. We don't need any more of that. The power consumption did go up, but a lot of people had been seeing rumors of 600 watts, 900 watts, 1,000 watts. Came in at, a lot of watts, around 450. But it did bump up the price of the 3090 by about 7%. But overall, when the RTX 4090 launched, if you compared its price to performance ratio at MSRP versus its predecessor of the 3090, it was offering a 60% better price to performance ratio, which is enough for a lot of people to get really excited about. However, the RTX 4080 was a bit less exciting. It still offered a large generational performance uplift. The 4080 versus the 3080 10GB offered a 49% performance uplift. Its VRAM capacity also increased by 60%, going from 10 gigabytes up to 16 gigabytes. And a lot of people, especially people trying to play at 4K resolution, but even pushing in a 1440p or ultra-wide 1440p, were starting to feel the limits of that 10 gigabytes. So the 60% VRAM uplift was also not to be ignored. It came in at the same power consumption despite having 50% more performance and 60% more VRAM, but its MSRP was increased 72%, giving its price to performance ratio of negative 13%. It has 13% worse price to performance than the 3080 10GB, both compared at MSRP. And that was hard for a lot of people to stomach. Now, you might be like, well, the 4080 is priced the same as the 3080 Ti. That's true. So after we look at this chart, we're also going to look at this chart arranged by its pricing predecessor rather than its namesake predecessor. So we got a lot to talk about here. Also, you might be wondering, where are all these numbers even coming from? Well, I was, I'm looking for my hardware news for my videos, and I found this on our hardware, posted on Reddit. Looks like the original information is coming from 3D Center, and they did an interesting post with this chart, and then this user has done a little bit more organizing of the information as well as rearranging it into this table, which looks extremely interesting as well. Now, where does 3D Center get all of their data? Well, whenever new card generations come out, they track the launch reviews of a whole bunch of sites and then average them. I often report on these giant meta-analysis results because, one reviewer might be able to test, 10 games at a few different resolutions and a few different GPUs. If you then average the results of a whole bunch of reviewers, outliers start to disappear, and you start to get, a really accurate picture of the actual relative performance. Anyway, so that's where a lot of this information is coming from. When we get down to the 4060 and the 4060 Ti, the data is coming from Nvidia's own published information, which I've already reported on for this channel, but the launch reviews are not out yet as of the time of filming. Anyway, let's continue with the video. Sources will be posted in the video description. So the 4070 Ti. This one, after the whole debacle of they wanted to call it a 4080, despite being not a 4080, they did decide to rename it as the 4070 Ti and decrease its price from what they had originally planned. But, called a 4070 Ti and compared with the 3070 Ti, you could see a performance uplift of even up to 44%. I think in my testing, I saw was a little bit less. No, I think that is reasonable. Yeah, about 44% performance uplift here. Also, VRAM. The 3070 Ti was very hungry for more VRAM at 8 gigabytes. Jumping up to 12, we get a 50% VRAM uplift, and the power draw stays about the same. However, the MSRP increased by 33%. So when you give somebody 44% more performance, but you increase the MSRP by 33%, we end up with the price to performance increase over its predecessor only increasing by 8%. And again, the most exciting thing about a new GPU generation is generally the price to performance ratio getting a sudden jump, where now my money buys me a lot more performance than it did before the new generation came out. That's why people get excited for a new generation. We've got the 4070 coming in versus the 3070 with 27% more performance. 50% more VRAM. Once again, getting that 12 gigabytes instead of 8 is very welcome. Actually draws less power than its predecessor, but the MSRP jumped 20%. So when you get 27% more performance for 20% more money, you now have only a 6% price to performance increase. And again, compare that to the 4090 that was offering us a 60% price to performance increase. This is the big number that people get excited about, the price to performance ratio generation to generation, and it's just not here. So now if we go into NVIDIA's, if we use their own information for the comparisons, we're now going to be seeing the 4060 Ti 16 gigabyte coming in at about 13% more performance, doubling the VRAM versus the 3060 Ti, coming in with drawing 18% less power, but the MSRP is jumping up 25%, so $100 more, meaning its actual price to performance ratio is going to go down 10%. It's going to be 10% worse price to performance, although you do get that double VRAM capacity, which is certainly welcome. But what if you compare it to the card that is launching in the next day or two here, as of the time of filming, the 4060 Ti 8 gigabyte. It comes in with around a 13% performance increase when you're not factoring in frame generation and all that. Against the predecessor, it has no extra VRAM. Its power consumption does go down 20%, and its MSRP stays the same. So at least notice that this is the only one so far where they did not raise the MSRP. And anyway, it comes in, so it will be giving us, 13%-ish more price to performance. Interesting stuff. That's not a massive amount to get excited about. However, it's at least better than negative 10% or 6% or 8%, and it's better than negative 13%. But again, the card people got excited about was the 4090, offering this large price to performance increase generationally. Now, Nvidia has also announced their RTX 4060, which should be coming in with a decent performance bump. By the way, if you're like, didn't Nvidia publish 15% or 18%? Again, this information is taken from 3D Center, and I believe they're looking at the, I think they were taking the charts that Nvidia published and filtering out some of the DLSS 3 results, and I think maybe even some of the ray tracing results, and trying to focus on the rasterized performance uplift in this chart. Anyway, it is, so this one's interesting because we actually get 9% less MSRP. The 4060 will actually cost less than 3060 12 gigabyte, which is nice. It will offer more performance, and the kind of downside is the VRAM capacity decreasing to 8 instead of 12. That's easier to stomach the lower the price point gets because you're more likely to turn down graphics settings anyway, but still, it's annoying to see this little bit of a caveat where a lot of these cards were getting more VRAM capacity than their predecessor, other than the 4090, which honestly didn't really need it. The 4060 is not only not getting the increase, it's getting a decrease there. The power draw is going down though as well, and with the price decrease combined with a performance increase, the 4060 is interestingly looking to offer a 30% price to performance increase over the previous generation. So as long as the 8 gigabytes of VRAM is fine, then at least this one actually looks like the 4060 might be the most exciting card since the 4090. It just has the, unfortunately, the VRAM capacity goes down along with that. Now, this is one way of looking at it, and again, it should be pointed out that this is not factoring in new features like AV1 encoding, and the price to performance ratio doesn't factor in the power draw decrease, which does save you money over time, and that is something that's here in this chart, but again, not factored into the final price to performance ratio. You also do get features like frame generation, which is a very good feature in certain situations, but it is situational. Anyway, let's go ahead and jump down to this version of the chart, which I think is also interesting. So this is now saying, what if you compare, instead of name to name, price to price predecessor? So compare each, what is the price to performance ratio doing at the same price point, not the same name point, if that makes sense. Now, they're going to be using the 3080 12 gigabyte in this chart as a comparison point. But the 3080 12 gigabyte never was given an MSRP, so this chart is going to assume that its MSRP was a $100 price bump from the 3080 10 gigabyte. Anyway, so with that in mind, let's cruise through this a little bit quicker. So the 4090 is really still in the same general place that it was. Again, compared to against the 3090, it did get an MSRP bump, so they're not exactly the same, but there's still our 60% uplift. Now, the 4080 does look more attractive when compared against the 3080 Ti, which also had the ridiculous $1,200 MSRP. Because in this case, it gives us 33% more performance at the same price, and that is a 33% price to performance ratio increase. The problem here is that the 3080 Ti was an obvious cash grab during the crypto boom, where they gave a small performance increase to the 3080 and then charged a massive price premium for the extra 2 gigabytes of VRAM and a few percent more performance. So again, compared against that card, which by the way, when that card launched at the time, I'm not gonna go dig up the video, I did mention that I felt like Nvidia would be trying to reset the pricing classes for the next generation and use these as justifications to charge more next time. And hey, look, they did. Anyway, the 4070 Ti would be compared against the 3080 12 gigabyte if you call the 3080 12 gigabyte again, assuming an $800-ish MSRP, which it was never actually given, although it is a lot of what it sold for once crypto kind of crashed a little bit. So for $800 price, in other words, at the $800 price point, we're getting about 14% more performance and a decreased power draw. So 14% better price to performance ratio with less power consumption and the same VRAM. The 4070 Ti is priced the same as well, at least not the same, but the closest to the 3080 10 gigabyte. It's actually $100 more. So if we use that price comparison, so again, you could do it either way, right? The 3080 12 gigabyte didn't really have one. You could compare it against the 3080 10 gigabyte, which is $100 less. The 4070 Ti is $100 more by MSRP. It's a 19% performance increase there. Does get you the 20% more VRAM and a lower power draw, but at a higher price, it's now a 4% performance increase. So basically stagnation plus a little bit of extra VRAM. Again, not what people get excited about with a new generation of GPUs. The 4070 versus the 3070 Ti do cost the same amount of money. This is the $600 price point. It's 19% more performance with, and 50% more VRAM and lower energy consumption, but only giving us about a 19% better price to performance ratio, given the, again, coming in at the same price with a noticeable but, modest performance increase. Now, the 4060 Ti 16 gigabyte version, again, we're going off of the Nvidia launch info, coming in versus the 3070 at a, basically the same performance. It will get double the VRAM and lower power consumption. So basically, you're getting no price to performance increase, but you are getting double the VRAM capacity and lower energy consumption, your AV1 encoder, frame generation, all of that. But again, the raw performance uplift, yeah, there you go, 1%. All right. And the 4060 Ti 8 gigabyte versus the 3060 Ti, they're coming in at the same price with about 13% more performance and lower power consumption with that 30% number. And again, we've got the 4060, we've already talked about it. With this one actually doing the 30% here. So looking at it this way, there's at least no negatives. So if you're buying at the same price as the previous generation, we at least avoid the negative 13% on the 4080. But again, the 3080 Ti did not make sense at its MSRP other than as a cash grab anyway. So what do you guys think about all this? I understand that, if you asked Nvidia, this is a bit unfair because the price to performance ratio is ignoring things like the additional VRAM, the lower power consumption, the AV1 encoder, and frame generation. And that's true, but all of those things are situational. I mean, the lower power consumption is always nice, but a lot of people aren't going to notice a few dollars difference on their energy bill. It might help you get away with a lower, not having to upgrade your power supply. That's certainly true. The extra VRAM capacity is certainly nice. So that is more noticeable. And frame generation, I've done a whole video on it. Frame generation is a good feature. I really like the feature. I primarily play graphically demanding single player games, and that's where frame generation is the best fit. However, it is situational. Like I said, single player games. If you're playing competitively, it's not useful. So that rules out a lot of people's main use case for their gaming PC. And then even in single player games, it's a win more feature. So how should I put this? When I used to play Hearthstone a lot when that game first came out. So it's a deck building, not a deck building game, but you build decks of cards to then compete with, right? Now, the reason I'm getting into this is not that you need a 4090 to play Hearthstone. You certainly don't. But when you're deciding, should I put a certain card in my deck, some cards sound really good, but they're not, because they're only useful when you're already winning. So they're a win more card. So they're not going to help you win a game that you're losing. They're going to help you win in even more dramatic and exciting fashion when you're already winning. And that's how I feel about frame generation. Frame generation is at its best when you already have a high frame rate. So it's a great way to take advantage of a high refresh rate monitor when you're already getting a good frame rate. So can it boost you from like 40 FPS to over 60 FPS? Yes, but you wouldn't want to use it in that situation for two reasons. When you want to go from 40 FPS to 60 FPS, you're usually wanting not just more visual smoothness, you're wanting better responsiveness to the game, and frame generation will actually reduce the responsiveness a little bit. It's not that bad when you're at a high enough base frame rate, but when you're already at a low, not very responsive frame rate, that's where the latency penalty matters, and we wouldn't be advised. Also, because it's interpolating two frames, and inserting a frame in between based on the data from two real frames, the farther apart the two frames are in the scene, the harder it is for the AI to get the interpolated frame correct. Which means, in other words, if a scene is moving quickly and you have lots of real frames, there's still not that much difference between the two frames, so the interpolated frame can actually look really good, almost identical to what it should. Whereas if you're at a lower base frame rate, your real frames are farther apart, so there's a larger difference between the two images that the AI algorithm is now trying to generate a frame from. And so, of course, if there's larger differences between the real frames, there will be more trouble with the reconstruction, right? So basically, if you're at a low frame rate, frame generation is not very useful. If you're at a high frame rate, the image quality is actually really good in most situations, and the latency starts to not really matter in a single player game. So for me, a lot of times, it's kind of the 60 frames per second number, just to throw that out there. Obviously you could swing a little bit more in either direction, depending on the game, how quickly it's moving, your personal preferences and tolerances. But for me, if I'm at around 60 frames per second, frame generation can boost me to over 100 frames per second a lot of the time, and still look very good, because there wasn't that much of a difference between the two frames it's generating a frame between, and it will still feel very responsive. But the problem is, it's not raw performance to help get me to 60 frames per second if I'm below it, right? It's missing that piece of the feature, which is where it's not the same thing as raw performance, plus the fact that it's not available in every game. Like the games I'm playing right now are The Last of Us Part 1 and Jedi Survivor. Neither of them have frame generation, right? So it's situational in that not every game has it. It's situational in that not in the game you're in, you need to be at a high enough base frame rate already before it's useful. And it's also not going to be useful in competitive games. So I think this price to perform. I think Nvidia wants this price to performance ratio to include frame generation. But while frame generation is a good feature, I think it is a value added feature for single player gamers. It's not the same thing as raw performance, because raw performance isn't situational and frame generation is. What do you guys think? Is this a good summary of the entire 4000 series? Like I said, I'll link things in my video description, and I'm gonna go get to work. I hope all of you have an excellent day.